Okay, keep your hands up. Who converted to SQLite? You're an influencer. All right, so our next speaker is Stephen Margheim, and he's software engineer, which is now developing his new framework. And he will tell us a little bit more about Yippee. Did I say that correct? Yes. About Yippee and the philosophy that stands behind it. So, Stephen, the stage is yours.
Thank you. Okay, can you hear me well enough? All right. So, as Lucas said, I'm Stephen. You can find me basically everywhere on the internet at Fractaled Mind, and I blog at fractaledmind.github.io. Nice to meet you all. Those of you I met last year, nice to see you again. Those of you I'm meeting for the first time, nice to meet you. You might be familiar with, this is a small selection of some of my open source projects. Plume is actually my newest project. If you're interested in learning more, I'm introducing it to the world next week at Ruby Kaigi, so keep your eyes out for that YouTube video. But that is a parser for SQLite's dialect of SQL in Ruby. If you do know me, you likely know me for the work I've done to make the Ruby ecosystem and Rails, the framework, the best way to build web applications using the SQLite database engine. And just because I have a captive audience, I thought I would take the opportunity to plug the course I had the opportunity to make earlier this year with Aaron Francis to sort of lay out everything that I know and everything that I think about how to build incredibly high leveraged applications with Rails. So that course is called High Leverage Rails. You can find it at highleveragerrails.com. It is a paid course, so this is an ad, but I have disclosed that, so you cannot sue me now. I have been working for the last, 3 years or so with Joel, who spoke yesterday about one of his open source projects, Literal. He maintains a number of projects that you also probably know about, Flex or QuickDraw, and a number of others. And we had the opportunity to have a longer, more in-depth conversation about how we think about web development on the podcast that he runs with his co-host Colin, 2 years ago or so. And those conversations, the short one that we had and recorded and the many longer ones offline, led us to start to realize that we shared a really deep similarity when it comes to taste. And taste is something that is hard to define and hard to put your finger on it and hard to get a sense of whether or not you share it with someone without just talking a lot and working together some and seeing and comparing code that you like and code that you dislike and why do you like this and why do you like it slightly more than that. But as we talked, we came to appreciate that we had a really similar vision for what really beautiful, powerful, simple developer experiences could and should look like. And we realized that we were both interested in trying to make as many of those things real as possible. So we sort of started off on this crazy project without like a ton of planning or direction to see like what would it look like to try to build a new web application framework from a blank sheet of paper, and to do so in a way where the very best, most interesting ideas could be completely separate from the application framework, and could just be gems that anyone could use. You could use them in a Rails app, you could use them in a Hanami app, but you could also use them inside of a framework that was designed to be philosophically and tastefully aligned with them. And that is what led us to starting what we call the Yippee project, a project to make web development exciting again. And I'm going to be upfront with you, all right, from the outset, that this is a teaser trailer. I'm not going to be showing you a GitHub URL at the end of this talk, because we don't have one. I mean, we do have one, but it's private, and half of the code in there doesn't work with the other half of the code because everything is changing all the time. But what I do want to do is I want to take this opportunity to give you a taste of where we're at, where we're going, and what the vision is for what this thing is about. And so in order to do that, I thought we would just break things down into two parts. The first part is pretty straightforward. I am going to say a lot of things about a lot of things. It's just going to be a bunch of bullet points in slides and some code samples. And then I'm going to do that relatively quickly because I want to save enough time for us to just talk. There's like literally 1,000 different discrete interesting ideas that Joel and I have talked about for a long time, and I don't know like what you would be more interested in talking about. So I'm just going to throw a whole bunch of stuff at you, and then you respond back, hey, I'd like to go a little bit deeper here, or there, or there, or all three of them. So I would like to actually have a longer Q&A session. And then, of course, we can continue the conversations over the next 2 days. Now, as I said, this project is probably best to describe as vaporware. It isn't like fully vaporware. There's lots of code on my machine and Joel's machine and in different repositories. But for the sake of setting expectations, I'm going to say this is vaporware. I am presenting a vision. Basically, everything I'm going to talk about today, we have working code experiments with in a few different things. So, but at the very end, I'll give you some of our harebrained ideas that we haven't experimented with in code, but have talked about and thought about. So we will get to fully vaporware parts by the end of the talk. So what are we going to talk about? I say we. What am I going to talk about? I want to walk through some of the key elements of a web application framework and just share with you what we're thinking. So we're going to start with persistent data. What are we doing there? Then I'm going to talk about the model layer. What are we thinking about at the model layer? Then we're going to move up to the controller layer, the view layer, talk some about testing, and then hosting and deployment, and then finally accessories. And now you have a very clear sense of what the rest of the talk's going to look like. We're going to walk through bullet points. It's exciting stuff. All right, persistent data. This was one of the very first decisions that Joel and I made because we shared a very similar thought from day one, which was, what if you just made a web application framework that only worked with one database? Like, why do we need options? Genuinely. Like, it's great that there are web application frameworks that have adapters for all of the different databases. Like, that's genuinely great. But those things exist. How am I going to outcompete? You know, you gotta make some cuts, and less is more. And what's interesting is if you make a decision at the beginning, you say, you know what? I'm going to build a framework that only works with SQLite, that is only ever going to work with SQLite. Some interesting things start to come up because now you can really target the exact, unique benefits of that database. You don't have to take the subset of features that are common to all the databases and see what you can do. It's like, all right, let's see, what juice can I squeeze out of just SQLite? And when I say SQLite only, I mean it. There's going to be a SQLite database for your primary data. There's going to be a SQLite database for your cache data. There's going to be a different SQLite database for your job queue. There's going to be a different SQLite database for your message pub. There'll be full text search on top of any of those databases that you want, all that set up. Like, there are going to be a lot of SQLite databases and only SQLite databases, and it's going to be beautiful and exciting. Now, one of the things that I have been talking about for a while, but is genuinely worth noting, like when you go all in on SQLite, it really does change the way in which you think about how to architect a framework and how to build apps on top of that framework. It is genuinely true that when you are using SQLite, N+1s are a feature and not a bug. And I'm going to just take 2 minutes to try to convince you of that fact. What is, philosophically, mathematically, the fastest possible read that you could make from a relational database? What are the characteristics that you would need, right? You would need an index, right? So if you're making an indexed read, way faster than a non-indexed read. If all, or the large majority, but definitely all, if all of your data is in the engine's in-memory cache, right? The database no database engine today is constantly reading and writing from disk. They have a pool of memory and they keep data around in memory. So if you make an indexed read where all of the data is already in memory, and there's no latency, no HTTP latency, no interprocess latency, no serialization or deserialization, then you have like the definitionally fastest possible read in the world. So how do you make more reads like that? Well, the simpler your queries, the easier it is to have indexes that cover them all the time. Where do we hit queries where the index falls down? It's like, well, I kind of, I need to join these 3 tables in this particular way with this one CTE, and then I get the data that I need, and I've minimized HTTP handshakes, so I'm doing it, and that's good, but I have a really complicated query to cover with an index. Or you have these complicated queries that are less common. So they're not kept in the hot paths. The database engine is like, yeah, if I see this every now and again, I'm not going to like keep this data hot and fresh. If you just write a whole bunch of really small queries, select these columns from that table and these columns from that table and these columns from that table, and I'll merge them together in Ruby land. It's way easier to have a much larger number of the fastest possible read queries in the world. Like you can have many queries that execute in 2 nanoseconds. And when there's no serialization overhead, there's no latency overhead, like there's literally no reason to not have 200 queries per request. And in fact, you can way increase your index hit rate, your cache hit rate, and that is going to make your whole application faster. So how does that change how you think about a web application framework? There are many ways, and we'll talk about some of them as we go. But I really want to hit this point hard. The fundamental reason that we are going all in on SQLite is that it is the only database engine in the world that has wide adoption and extensive usage, and you can feel confident that it like works, where latency effectively does not matter. Like there's just not really much of a point in thinking about it. And that really changes how you think about building applications. So we wanted to like explore all of the ripples. So persistent data equals SQLite. Now, it does come with some interesting ripples. The very first, most important one that we realized like on day one was, well, if I want all of these really awesome benefits, all of these performance benefits, there's really only one type of deployment that makes sense. And that is single machine deployments with persistent file systems. If you're doing anything else, you're not going to reap all of these awesome benefits. So we decided day one, like literally 3 years ago, we're having conversations like, this is what it's going to be. And it has not changed, and it will not change. We are building the best web application framework in the world for building single machine deployments that exclusively use SQLite for any and all persistent data. Now, if you're not into that, I'm confident that I can get you into it over the next couple of years. But also, there are a lot of great other options. Use Hanami, use Rails, use whatever tickles your fancy. But if you accept these two constraints, it is amazing how much leverage is given to you. And we're going to explore some of that. But this is the original core defining constraints. What if you had a framework that only worked with one database, and you're interested in building apps that you only deploy on one machine? How far can you go? And as this project moves its way out of the vaporware stage into the software stage, I'm going to be more and more excited to show you how far you really can go. I will just say now, I'm pretty confident this is true, except for a couple people over there. However far you're thinking right now, like this is the limit. This is the mathematical limit of how far I can go. You're at least one order of magnitude wrong. And I look forward to building an app and proving it to you and then laughing in your face. All right, let's move on. Model layer. What do we want to do differently here? Well, we want to have a really object-oriented approach that very cleanly slices the essential parts of a model. There's a lot I really love about Rails, and when you have a scenario where your web resource, the way that you represent the world to the HTTP response, has a very direct mapping to your model, the way that you represent the entity to your application, and that entity has a very direct mapping to your table, there are very few developer experiences that can compete with Rails in that scenario. If you have a one-to-one-to-one mapping between resource, model, and table, that framework sings. As soon as you have a little bit of a gap, right? You're like, for the web page, I wanted to have one form, I say one name, but I kind of need to write to two tables, or I kind of want to represent this entity to my system as one thing, but I kind of need to read and write from two tables. Rails doesn't sing. There aren't really strong conventions there. And what we want to do is we want to really cleanly slice and define these types of objects. There is a resource. A resource is an entity that you present to your request response cycle. The model is the entity that you present to your application. The table is the entity that understands the schema of a particular persistent table on your database. A table is the most common type of a data source. Of course, you have other data sources. You can build a dynamic data source. That's what joins are. You say, I'm selecting some data from this data source. It's not mapped to a single table. It's this particular Cartesian product or scoped Cartesian product of these 2 or 3 tables. And then you can also have values, right? And if you define these layers really cleanly and really well, you can collapse them when they need to be collapsed, expand them when they need to be expanded. Yes, this is the accordion. We'll talk about it more in a bit. So we want to make it as easy as possible to work with the model layer, whether you've got 1 model per table, 3 models per table, 1 model for 3 tables, or some mix thereof. Now, in order to do this, this is like a remix of the repository pattern, right? What's the repository pattern in its simplest form? It's to say, let's separate the responsibility of talking to a data source from the responsibility of presenting structured data to our application. Let's make those two different types of classes. And let's define a really clear contract between those types of classes such that I can get data from the database and hydrate a model, and I can make whatever ad hoc queries I need against the data sources. But I'm just going to be honest with you, while I like the concept of the repository pattern, I hate the names. So I like these names better. But it's the same basic idea, and we are 100% borrowing it with some minor tweaks. The other defining characteristic of our model layer is that we are embracing query building as opposed to the sort of active record style approach of everything is driven through a model which is itself really just a table in this parlance. Right? So what would it look like to give you the full expressive power of SQL in Ruby from anywhere at any point to talk to any data source, to craft any data source, to craft any query, however you need it, whenever you need it, with as much ease as working with Active Record today. This is one of the use cases for having a SQL parser, one of the reasons why we started that project. But in general, it sort of shifts the way that you think about things. Say, like, we're going to have queries. And those queries, we can have relationships to tables or sources. They have relationships to models, like I go to a table to get the data. I take the data and I hydrate a model. So queries, tables, and models are going to be central, but they're going to be different things. Things that you can collapse together such that you don't need to see any of them. Right? So we can build a very active record-like interface where you don't need to have 3 different files or call 3 different classes. But behind the scenes, that's what's there, and you can eject into those layers at whatever point you need. So code sample, just to give you a little bit of a concrete sense what I'm talking about. What would a query builder look like in Ruby? Here we go. This is a query I use quite often to do basically tagging on top of SQLite. So here we are getting our artists, but we only want those artists that have certain tags. And so inside of this where condition, we need like a nested select. How could we make that easy to build? If you've ever done this in RL, then you will know that this is much simpler than RL. If you haven't, take my word for it. This is much simpler than RL. But beyond just having this fluent Ruby interface, at the very core, one of the things we're going to have behind it, I'm also really excited about, is this. Now this is going to look a little bit crazy for a moment. I'm going to give you a moment to like study it. And it might be crazy, I admit that. But it's also beautiful and profound. This is Ruby. This is a Ruby hash using basic Ruby primitives. You've got a constant, all. You've got a constant that maps to some sort of object, artist. This could be a class, this could be a module. We don't know at this point. We've got nested hashes. We've got some basic primitives. We've got like a Boolean true. We've got a method call on a constant. We've got an array and some primitives. Okay, but really study that this is just SQL. There's no extra words. This is just taking SQL and structuring it. And what this does is provide the most important missing feature that SQL has, which is composability. You can take that hash, that is the value there to the exist key, you can build that however dynamically you want. You can store that wherever you want in a constant, in a variable, and you can compose it incredibly easy, right? Like we know how to build Ruby hashes. We understand the composability that they provide. And if you have a terse, fully expressive, right? Like every single thing you can do in SQL, you can do in this way. Now you just have composability. And SQL plus composability is radically powerful. There's like all kinds of things that spin out of that. So these layers, you're going to see, like, we like layers. But having these layers of control they are the sort of defining characteristic of our model layer. So these are queries. These are how we are thinking about doing queries. That's the model layer. Let's keep torrenting. All right, controllers. What if you had a router and a controller in a single class? For those of you who have used it, you would think, oh, I have a sense. Okay, this is Rhoda. Yeah, exactly. Rhoda is a really, really cool idea. I don't have the time to get into it fully, but it's the idea of a routing tree. The core difference here is, let's just use Rails as an example. In Rails, you have your routes file. And at boot time, Rails goes and parses that text file. It says, okay, I'm going to build they build a state machine. So there's a source text, a parse step. That parse step produces a state tree. That state tree is stored in memory as a Ruby object, and then requests come in, and they match against that whole state tree to figure out what controller do I initialize and what action do I call. And what that means is that your startup time, your boot time, has to eat the cost of figuring out all of your routes. And you need to have computed everything that there is to know about every single route in your entire application every single time. And a routing tree just says, like, we know how code works. Like, what if we just execute code paths for our request to get to our response handler? So then, like, you don't have to do anything at start time. And it doesn't matter if you have 10 routes or you have 10 million routes, you have constant start time cost. Right? There's no added cost to having a million more routes, whereas in Rails there are. Like, you just have more stuff to parse. This benefit is really at the heart of the decision, on top of just like some taste preferences. But we're going to talk more about this. One of the central sort of goals we're shooting for here is every app, regardless of size, should start in milliseconds. Like ideally single-digit milliseconds. All right, we deserve so much better from our developer experience. Like we accept so much lag everywhere in every tool, and we shouldn't. And we should stop. And we should start kicking people who build slow tools and make them build fast tools. Fast is important. So 0 startup cost. Now, one of the things that we're really inspired by Rhoda and this idea of a routing tree, but we're building a completely different routing tree. There's no code shared. And we really wanted to focus on having a very flexible approach. What do I mean by that? What if you just want one controller per app? This is what Rhoda is and what Rhoda does, right? You have a controller. It's just like your app, basically, right? Cool, you can do that. What if you want to go the complete opposite direction? You want to go Hanami-style. You want one controller per action. Atomize everything. Let me have a class per action. Cool, let's make that possible. What if you want one controller per resource, like Rails does? Okay, I'm going to group actions together. I can take these 7 actions and put them in one class. No need to have 7 different classes for that. I'll just do one file. Yeah, all right, let's make that possible. What if you want one controller for all of your member actions for this resource, but a different controller for all of your collection actions for a resource? That should also totally be possible. All of these should be equally as easy to build and to run and be able to mix and match all of them however you need for whatever part of your application they are best appropriate for. And what if you had some parts where it's like, we don't need to even execute some code. Here's a freaking hash. Here's the key. Call this. All right, like O1. You have parts of your app where the routing is quite simple, where you don't have a lot of pre-logic or post-logic. Let's do that too. Let's do all of it, all the time, anywhere. How would you make that work? Well, it could look like this. So here are the code samples. All right, so this is a resource controller. This is Rails style. So controllers have a handle method. And this says, how do you handle this request as it's coming through? You have all of the HTTP verbs, and you say, all right, like if you're at this point and you're a GET request, let's just call this method. So here in the private methods here of this class, we define an index method. That index method would take the params and the captures and whatever all it needed, make some queries, do whatever it needs, render a view, response stuff. Collection actions at the top, member actions at the bottom, all in one controller. What if we wanted to split and we wanted to take our member actions and put them in a separate controller? What would that look like? It would just look like this. All right, we're going to make a new controller, call it controllers article. That object, like every Yippee controller, as we also saw from Joel's literal talk, is going to respond to toproc. So you can just say, delegate that. All right, so if you have the article ID segment, you match on that. I don't know what to do. Talk to controller's article. It'll manage that. You could also do some hash-based routing. Say, look, if you see at this point, right, so we break the route down as you're parsing, so this could be high or low. In this case, we're at the root controller. Like, look, if your route is just articles, you don't need to call and process the Ruby of the handle method. Just go straight to the articles controller. Also here, you see inline responding, right? So if it's not articles, if we're just on the root route, and it's a GET request, here's what you do. All right? So you can put a method call in there. You could extract this out into a method you call root or base or whatever, or you can just inline. This is obviously a single line proc. You could have a multi-line proc. We love callables. So those are controllers. Those are some of the core ideas. Those are the code samples. Got to move on. View layer. I don't know what else to say. Flex is great. If you haven't used Flex, genuinely, Flex is a lot like Tailwind in that you look at it the very first time. I had this experience with both of these projects. You look at it and you're like, ugh, what is that? That's weird. I don't like it. And then you try it and you're like, You've seen this meme? And you try it for another week, you're like, oh. If you haven't, so I'm just trying to make the point. You really do need to try it. You can't look at code and really get an appreciation for whether or not you're going to enjoy it. You will enjoy it. That's kind of the magical thing. You're Ruby programmers. Believe me, you will like building views in Ruby. I promise you, because you like Ruby. Just try it out. You'll see. It really comes with the benefit of being like highly testable. That's a nice side effect. Testing is important. We'll get to that in a bit. We're going to fully embrace all of Flex. You're going to have views. You're going to have components. You're going to have kits. If you haven't used kits in Flex, you can make building views so beautiful. These Ruby files are elegant pieces of code prose. We're going to take advantage of selective rendering. We're going to do some really cool stuff. You don't have to execute all of the code paths. Flex is a really powerful layer of abstraction, right? So you can say, I just need, in this context, we're not going to use turbo, but let's imagine like a turbo frame, right? I just need this turbo frame. I'm going to replace the content. Hit the controller, hit the view. I just need this. Flex can just no-op. Every method call that is not related to building that part of the view, just wait. I don't know. Ignore it, ignore it, ignore it, ignore it, ignore it. Oh, that's a turbo frame we're looking for. Cool. Now I'll turn on these methods actually doing something. Render, 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 end. Cool, done. Early return, send it back. Very fast. And you get tiny payloads over the wire. Really cool stuff. It's going to work with literal. Again, I don't know what to say. We took all of our best ideas. We put them in gems. The gems are great. You now know everything you need to know about literal. So every Flex component, every Flex view is going to be Yippee. Every Yippee component, every Yippee view is a Flex class that extends literal properties. Those two things work very well together. Yeah. Guess what? You are going to have hundreds of queries in your views, and you're going to love it because it's awesome. Do you know the reason why you don't have queries in your views? Do you know the actual reason? It's because if you put them in your views, you can't really tell if you're making 200 queries or 2 queries in one request. And we're like, gotta be safe. Can't have 200, so let's put them all in one place so that if I see 200 lines in this controller action, I know I fucked up. But if it doesn't matter whether you do 200 queries or 2 queries, if in fact it might be better for you to do 200 queries, I promise you it is better for your application architecture to put your data fetching next to your data use. In reality, it is better. The reason we don't do it in Rails, and we don't do it with MySQL and Postgres, is because we can very easily destroy our P50 performance just through recklessness. It's like, I've got 50 partials that I render in this view, and stuff sprinkles around, and you never really see the overview. You never really see, oops, this is the straw that'll break the camel's back. When you don't have that problem, you can embrace the benefits of putting data fetching right next to data usage. And it is better. Locality of behavior is a great thing, and when you can, you should, and we will. This is a sort of simple example. If you've used Flex or you've used literal, this will look pretty straightforward to you. When we have literal arrays, that'll be a literal array of albums, but an album here is a model, by the way, not a table. This is an immutable data object, not a thing with 200 SQL-making methods. All right, let's talk about testing. We're Rubyists. We like testing. We're Rubyists too. We like testing. So this is our goal. You should be able to run an application suite of 10,000 tests, browser tests, unit tests, system tests, in 1 second, maximum. I mean, it should be 100 milliseconds, but I'm giving myself a little bit of wiggle room, okay? This is what we deserve. Like, we're adults. We're professionals. Like, we deserve, like, actually good software. Here's the thing. This is possible. Let's think about what we would need to make it possible. Like step number 1, absolutely. You need to be running tests on every single core of your machine. We all have multi-core machines. How many of us are running single-threaded tests? A lot of us. So you absolutely need to be running tests across your multi-core machine. But importantly as well, you need to saturate those cores. Like I love my laptop. I don't need to treat it like a baby. I need to use it. Saturate your computational resources. Now, QuickDraw is the testing framework that is, again, like, take all of the very best ideas, extract them into completely isolated and separate gems. This is just a completely generic testing framework with a test runner, and the defining characteristic of the test runner is this. It has a custom-built work distribution system that's going to use every single one of your cores as much as possible. It's just going to hammer your cores to run your test as fast as is computationally possible. And if you like fully saturate all of your cores on, I've just got an M1, you know, guess what? You can run tens of thousands of tests in less than a second. What else are we going to do to make 10,000 tests of all kinds run in less than a second? Yeah, we're going to take advantage of SQLite. In-memory SQLite databases are incredibly powerful. This is why Rails sets this as the default as well. So if you have one in-memory database per thread, and there's multiple threads that you're going to run per core, your data fetching is microsecond. I mean, in simple cases, it's crazy, nanosecond. But you need to manage this a bit. So let's think it through. We should make sure to use a single fixture step. Right? One time, set up your fixtures. Do it in the minimal number of SQL queries. Like this needs to run in milliseconds. And now we have a database that we use as a template. And we clone our in-memory databases, right? So if you spin up 100 threads across 10 different cores, you don't want to run 100 fixture steps. All right? That's overhead. So I'm just trying to walk you through some of the key sort of like thinking here. But run a lot of tests super, super fast. Defining characteristic of testing in Yippee. So the final sort of strategy we're embracing here to make this true, find and implement high leverage shortcuts. Just to give you one example. How do you test views today in Rails? Fundamentally, like what do you have to do? You have some Ruby code that you execute that produces a string. You then run some more Ruby code to take that string and produce a syntax tree. And then you take your test code to write assertions against that syntax tree. What if the Ruby code, when you're writing tests, produce the syntax tree instead of the string? The browser needs the string. The tests need the syntax tree. So if I'm in test mode, I should just have the Ruby code produce a syntax tree, save a step. And one of the high leverage points about Flex is that because it gives you this clean layer of abstraction, you can, in certain cases, make those methods no-op, right? That's selective rendering. In another case, you can have those methods build a completely different type of data structure than they would in production. It's very, I wouldn't say easy, it's not easy, but it is possible to have Flex drive completely different execution behaviors depending on these contexts. Selective rendering, no-op. Production, build out a string. Testing, build out a syntax tree. So testing, super, super, super fast. That's the number one goal. We want to run a whole bunch of tests really, really fast. We're going to be doing various different tricky and devious things to make that happen. I forgot I had that bullet point. Another example. If you haven't seen this project, this is a project, I believe it's written in Zig. They're building a new headless browser. It's only ever going to be a headless browser. I like highly constrained software, by the way. It runs super fast, right? Integrate into it, make a highly opinionated choice. Make system tests, browser tests, run super fast. All right, so just look for leverage and execute that leverage as much as possible. Let's talk a little bit about hosting and deployment. I hope that at this point you're thinking, this is an odd slide to have when talking about a web application framework. But frameworks should, in the modern day, take on more responsibility, in my opinion. You should constrain certain things and use those constraints to spend in other areas. So we want Yippee to spin up DigitalOcean or Hetzner machines for you. Yeah, give me an API key. They've got APIs. You own it. You pay for it. But I can write the scripts to get the machine set up for you. We also want to make deployment easy to do and hard to fuck up. How do you fuck up deployments? conceptually. Like, what's the mistake? The mistake is you mix different types of deployments because the primitives that are available to us today are too coarsely grained. We need fine-grained primitives. One type of deployment is deploying your app. You've got Ruby files. You make a change to the Ruby files. You want Ruby to execute differently in production. Version 1, version 2. Version 1 runs this Ruby. Version 2 runs that Ruby. That's an application deployment. Those are relatively well understood types of deployments for us to do well. Right? But it's completely different from doing an infrastructure deployment. I've got version XYZ of this C utility I'm using, and now I want to upgrade it to version XY1 to fix a security patch. It's very easy to send both of those types of deployments to production at the same time. And you shouldn't. You should isolate your different types of deployments. You should do an infrastructure deployment when you need to do infrastructure, not change any of your Ruby. And then once that's done, deploy a Ruby change. And you can do them one after the other if you want, but you should always isolate them. And both of these types of deployments are completely different from making a schema change. If you need to change your database, make that change. Now, it is often the case that you need to orchestrate multiple of these types of deployments to get to the end state that you want. But by isolating them, it's much easier to do safe and sane deployments. But what do you need? Well, you need a deployment queue. You need a way to ensure that one at a time, start, wait till it's done, successfully done, cool, okay, move on to the others. But like for me as a developer, let me just say, make these changes, now do it, right? I don't want to have to make you be the deployment queue manager because, let's be honest, you and I will fuck it up. At least once, right? This is the kind of thing that software should do. So a framework should also manage a deployment queue. Here's another thing. YAML config is, this isn't recorded, right? This is just among us. It's a scourge and a cancer. And we should burn it with hot fire. So here's a promise I'm making to you about this vaporware that you can't see the code of it. It's not going to have YAML config, okay? For some of you, that'll make you sad. For those people, come talk to me later. We can do some therapy. But there should also be very minimal generated configuration. Rails, what was like the defining characteristic of Rails? What made it spark 20 years ago? Convention over configuration. Run Rails new today. Tell me how many configuration files you have. Okay, yes, we're going to embrace Docker for infrastructure. Docker is a really great tool for managing your set of infrastructure dependencies. Oh, I thought I had a bullet point there. Whoop, 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 whoop. But you don't need to use Docker for your app. Infra deployments, yes, Docker. App deployments, no, Docker. How do you get really fast deployments? Don't build a full Docker image from scratch every time you change a character in a Ruby file. Okay, that's how. So we're not going to do that. Because we also want deployments to be sub-millisecond. Okay, let's talk about accessories. Web frameworks should be way more generous. We deserve batteries included frameworks. What are some batteries? You should have exception monitoring. It is ridiculous to imagine putting an application in production, even a side project, a thing for just like your mom and your cousins to plan their Disney vacation. Whatever it is, if it's on the internet, it should have exception monitoring, including CSP violations. Right? Just like you should be able to see what has happened and gone wrong in your application. That should be available to you. You should have performance monitoring. You should be able to see, like, how is this application actually performing? Where are bottlenecks? Where should I go and look to make things better? That should just be there. You should be able to monitor your background jobs. Again, like, you just need to be able to see things. You can't make intelligent decisions without information. And the information has to be available to you. Otherwise, it's barely information. You should have logs. Why in God's green earth are we having to pay for logs? Just show them to me on the screen. There doesn't have to be 1,000 features, but I should be able to see my logs in a usable way. You should be able to inspect your database. This is not rocket science. We're going to build all this into Yippee because it's what you deserve. We're adults. Now, if that doesn't get you excited, you're Polish. But eventually, it'll start to bubble up. You'll get some warmth. I understand. There's a certain coldness. I get it. I married a Russian. I understand the culture. But at some point in your heart, all right, it'll come. Now, I want to talk just a little bit about the philosophy here. Fundamentally, we are building a framework from first principles, right? Like blank sheet of paper. What would it look like to make the developer experience for Rubyists amazing in 2025? What are the tools and technologies available to us that we can build on? I want to be very clear. I love Rails. I work in a Rails app. I will continue to work in Rails apps for many years. Rails is great, but fundamentally there is no way that it can change the fact that it came into existence 20 years ago, and the world was very different 20 years ago. Yes, Rails evolves very well. As open source projects go, it evolves incredibly well. But there are foundational decisions that were made 20 years ago that they can never change. They're too deep in the very core of that framework. And there are things we can do if we just start from scratch. And we just rethink what's possible and what should be there, right? Like deployment should take less than a second. Tests should take less than a second. What do you have to do on day one to make those things true? Obviously as well, Yippee is grounded in an aggressive love of simplicity. We don't need the options that we think we need. I'm just telling you, you don't need 5 servers to run your web app. You don't. I will prove it to you. But in the absence of proof, I'm the one with the microphone, so trust me. You don't need different database engines. There's so much that we don't need. And with simplicity comes leverage. If you apply simplicity correctly, you get leverage. And if you apply leverage correctly, you get value. And that's what Yippee is all about. Where can we find simplicity that gives us leverage? How can we use the leverage to provide value to us as professional developers to make our lives not just better, but more enjoyable? This is what the accordion of complexity is all about. Give me freedom. When I have a situation where everything can be compressed, where I only need one file, and it can be my router and my controller and do my data fetching and do my rendering all together because it's really simple what I'm doing here and I only need 30 lines. Let me put all 30 lines in one file. Don't make me have 5 different files. But in the case where I'm doing something complicated, let me name each layer. Let each layer have a very clear relationship and contract to the other layers, strong conventions, and let me do that work. And I know for a fact, every single application that we have built or will build will have certain places where it's very simple and you could do it in one file, and certain places where it's quite complicated and it would be nice to have 10 different files. And you should be able to mix and match the degree of complexity that your application needs in the parts of your application that need it as needed. This is what it means to play the accordion. You expand in the places that need to expand, and you collapse in the places that need to collapse. And you aren't forced to always expand or always collapse because that's what the framework told you. And that's the only way that the framework works. And when you can expand and collapse as needed, where needed, then you can start to make music. And that is beautiful. So, couple wild ideas, and I also do realize I completely screwed my ability to do Q&A, but we can talk outside. Just a few, this is full vaporware, but I want to share with you. What does Bootstrap do? Bootstrap takes all of your Ruby and it processes it, and it gets the actual Ruby VM instructions. And then it takes all those VM instructions and it writes them to files. And then it says whenever Ruby needs to do stuff, it's like, don't reinterpret. You don't have to reparse all this stuff. Just execute the VM instructions. Now, for those of you who might not know, one of the most sort of famous taglines of SQLite, 30% faster than the file system. So very early on we thought, like, it would be kind of nice if we could have Bootstrap write to a SQLite database instead of to the file system. It'll just be a bit faster. And we started exploring that, and as we're doing that code, we're like, yeah, wait a minute. How do you get really fast deployments? You simplify things. Which is faster? Sending 100 files that total to 100 megabytes over HTTP to another server, or sending one file that totals 100 megabytes over an HTTP server? Well, I don't know, to be honest. I haven't done this experiment, but I think that there's a fair chance that the one file, and if it isn't faster, it is certainly a lot easier to ensure that you get a full, clean, successful deployment, right? I don't have a, whoops, 50 files made it, but the other 50 didn't. So what if we just like took your whole app, parsed it, got all the Ruby VM instructions, threw them in a SQLite database, and that's what you deployed? I don't know. That's a wild idea. We'll see if we build it. I don't know. Here's another wild idea. Well, there is another wild idea, but it's in my speaker notes. So we're going to look at the speaker notes for a moment. Oh, of course. Now I remember. What if you had purely declarative migrations? What does that mean? Don't tell me the migrations you need. Just say, this is my schema, and let me make some edits. No, this is my schema. And then the framework migrated you from schema A to schema B in the way that was safest and fastest. We already talked about, like, you should be able to deploy in less than a second. You should be able to, in fact, here's the wild idea. Run CI from your laptop. Once everything is green, then do deployments. And all of that should take less than 1 second. That's a wild idea. There are a whole bunch of other wild ideas. Most of what Joel and I do is talk about wild ideas, and then every now and again we actually do some typing and make some software. But mostly, it's wild ideas. So, technically, I spoke for 57 minutes, but are there any questions?
I guess we can take one.
I told you I would save time for questions, though. I'm a man of my word.
Well, we're 1 minute past the time, but we'll make an exception.
Okay, thank you for your presentation. It was brilliant. I have some notes. So the SQL as a hash representation was beautiful to me. Another one, the queries in the views. In my mind, it was like if the database is so fast, you can treat it as a variable. Yes, that's a good way of saying it. My question is about the routing trees, because I'm not familiar with Rhoda. So the cost is, for me, is like the cost is moved from the boot time to execution time, right? So if the request comes, how do you find the controller that should handle the request? Thank you.
Yeah, so it is, the cost is moved from boot time to request time. Here is the core thought. Is Ruby slow? And like, what's the, yeah, okay, I mean, that's a whole debate, but you know what I mean. Simplicity and leverage. Which is more important? To have every single development experience, every single production experience have to eat 5 seconds of boot time. Joel did a poll a while back, right? Like, write an assertion, assert true into your application. Run just that one test. How long did it take? The average time was 5 seconds. Some 3 seconds, some 12 seconds, right? That's an incredibly large startup time for your app and for your tests. And Ruby is fast enough, and you don't have to process everything, right? Like you just hit the code pass, you start finding your way through the tree pretty quickly. And then finally, like if you really have hot paths, you do direct hash-based routing. This is O1, like this is super fast. So you always have the hatch. If you have a truly hot path, you're like, I want this to respond in 5 milliseconds, right? And then you're optimizing everything. Then you're gonna lean into this hash-based routing. But in a lot of other cases, really everything is fast enough. And the benefit of those super fast startup times is what allows for the possibility of tests plus deployment in less than a second. And that is like, we're not going to give up anything for that.
All right. That sounds really great. Just one disclaimer, Steven, regarding YAML. We were recorded, so it's not between us. But, you know, we can always talk with Darek.
Just to big YAML, I love you. I use lots of YAML configuration. Big fan, you know. Screw TOML. So don't cancel me.
This is the part where nobody is going to reach. I hope they will. Okay, we'll just make marketing around that. Ladies and gentlemen, Steven Margheim.